I would like to welcome Team 11 from Vitae High School. Their topic is about Lignum Vitae Academy. Please welcome Team 11.
Good afternoon, ladies and gentlemen. This is our school, Lignum Vitae Academy, Routine 11. I'm Weldy, this is Justin, and this is Shane. This is our catalog. First, we'll talk about energy generating and storage, and next, we'll explain the healthy learning environment that our school boasts. And finally, we'll have our conclusion in summary. Shane will show you the rough model of our school. For the main material, our school is mainly made of wood, such as walls and floors, and for frame structures and fences, we use aluminum alloy, which can be reused after melted. Our school used insulated glass, which can reduce heat transfer. And by the way, we'll stick some eco stickers on the glass, so the birds won't strike it and die. Energy generating. We have solar panel and power generating tiles. The solar panel will be introduced by Justin.
We have installed solar panels on the rooftop, and we use solar power as the main energy source for our school. What's more, rather than just focusing on the efficiency of the solar power generating waste, our priority is to minimize the solar panels' environmental burden and make good use of the recycled materials from solar panels. First, I will introduce a pollutant that will produce when manufacturing the solar panels. And this pollutant is called solar panel waste slurry. This black sludge-like substance is produced when cutting silicone wafers during the manufacturing process. And this substance contains a lot of harmful chemicals in it. If it doesn't handle properly and enter to the environment, it will cause soil and water pollution. However, this solar waste slurry is not. Wood is also to send solar panels into a heating machine, and the machine will soften the solar panels. Then the internal equipment will separate the solar panels into two parts. You can see the upper layer is the glass sheet, and the lower layer is the solar cells. The two methods can separate the solar panels and extract some useful materials.
Recycled, and the surface is made of old tires, and the interior part is made of recycled aluminum. The most important thing is that it can be used in most conditions. No matter how heavy the rain is, no matter how dry the condition is, it can all work as usual. Next, I'm going to tell you how it works. So basically, these power generating tiles are consist with three parts, which is electromagnetic generator, a composite tile, and people. So when we people step on these power generating tiles, it creates a small vertical force. So it is basically our weight when we step on it. We press down these power generating tiles, and the electromagnetic generator inside creates a rotary motion, and it can generate electricity. Next, we're going to introduce you two ways that we use to store the energy, which is hydrogen storage and pump storage hydroelectricity. So hydrogen is a low pollution way that we can store the energy. We have to electrolyze the water, and it can turn water into hydrogen and oxygen. When we want to store the hydrogen inside a high pressure tank, or we can store it as a liquid hydrogen. When we need to use the electricity, we have to use hydrogen fuel cells. So we insert this hydrogen and oxygen inside it. After it processes, it turns into electricity. Besides electricity, it only creates water, so it is basically a zero or low pollution way that we can generate electricity. Although hydrogen is a high effective way that we could use to store the energy, it is dangerous, it is flammable. So we want to store hydrogen underneath the water storage layer, which we'll mention it later. So if this hydrogen accidentally explodes, this water layer would absorb most of the shockwave to make our students safe and our teachers safe. Next, Wally are going to introduce us pump storage hydrogen electricity.
Thank you, Shane. The benefit that pump storage hydroelectricity system has is that it can store and generate electricity. It can both store and generate electricity. This is its operation. First, during low demand periods, such as at night, the system will use low electricity to pump the water from a lower reservoir to an upper reservoir to store the energy as potential energy. While during high demand periods, such as daytime, the stored water is released from the upper reservoir back down to the lower reservoir, which was mentioned earlier as above this hydrogen storage tank. And the potential energy will convert into kinetic energy, then into electrical energy to generate electricity. After we talk about energy, the recycled resources are also important. So we have water recycled and leftover recycled. The water recycling, we collect the rainwater and then reuse it, so the rainwater can be valuable. Demonstration. Shane will show you this is a simulation of how our ground looks like. The first layer should be plants, and the second layer will be the dirt, and bottom layer are the rocks. When the rain falls down, the water will penetrate through the dirt and to the rocks, while the rocks will hold the dirt, so the dirt won't go down with the water. And when the water goes to the bottom, it will be collected by pipes, and the pipes will direct the water into a collection tank, and then reuse the rainwater. And you might think, what if the rain falls on the roof? Well, not a big deal, because we have a rainfall collection system installed on the rooftop as well. Our roof is tilted, which can make the rainwater flows down naturally and then be collected by pipes that would lead the water into a water tank. And additionally, the pipes will be painted green, so we know which pipes contains the rainwater. The stored water can then be used as restroom water or to watering plants. Next, leftover recycling will be introduced by Shane.
Now I'm going to prove to you leftovers is not useless. So we collect all the leftovers from our students or from our teachers. Then we want to put it inside this fermenter. The fermenter would chop all the leftovers into small pieces. And after it processes, it turns leftovers into organic soil. We can use organic soil to plant our trees, our flowers in school. That can make them grow better and grow healthier. Besides that, we also use biological deodorization systems to prevent smelly gas that produced when the fermenter is processing. Next, we are going to introduce you two unique designs which can make our students to have a more healthy and a more comfortable learning environment, which is roller shutter and wind tower. Now, Wally are going to introduce us roller shutter.
Thank you, Shane. The roller shutter design is installed on the rooftop and can be used to adjust the temperatures. The main design. Most roller shutter doors you see are vertical. However, our design is horizontal, and it is created with black on one side and white on the other side. When the winter comes, the door will roll to the black side and absorbs most of the sun's heat to help warm up the classroom. And in summer times, the door will roll back to the white side to reflect the sunlight, which can help cool down the classroom. This is the data. The left bar chart is balls with different colors. You can see the black one goes up to almost 70 degrees Celsius. And the right bar chart is hard hats with different colors. And the solid bar is the average temperature increase, while the gray one is the maximum temperature increase recorded. We can see black one has an average temperature increase of 5 degrees Celsius and with a max of 12.7 degrees Celsius, while the white one has and average temperature increase of only 0.7 degrees Celsius, and with a max of only 2.5 degrees Celsius when the air temperature is 35 degrees Celsius. With these two experiments, we can know the black color can raise the temperature while the white one can help cool the room down effectively. Speaking to different colors can adjust the temperatures. Our uniform can use the same principle. For example, in winters, we can use green, black, or purple uniforms to absorb the sun's heat and to help warm up the students. While in summer times, we can use white or yellow uniforms to reflect the sunlight, which can help cool down the students. Next, the expense. The area that our design occupies is about 648 millimeters squares, and one side, a unit of measurement for rolling metal doors, equals to millimeters squares divided by 0.3025, which you can know the area is about 2,142 tsai, and one side equals from 350 to 900 NT dollars, which you can calculate that the whole design cost around 1.3 million NT dollars. Next, wind tower will be explained by Justin.
Our wind tower design is inspired by the Cheng Kung University in Taiwan, and this is the actual picture. Next, I will introduce our school we built in the Minecraft. You can see in the picture. We built the chimney at the rooftop, and we also add the ventilation opening at the back of every classroom. Next, I will explain the principles behind this wind tower design. The principles contain thermal convection and air pressure difference. In short, when the inside air was heated by the human activities or the sun's heat, the hot air will flow up along the roof and then emit through the chimney. At the same time, the outside cooler air which has higher pressure, and it will naturally flow into the classroom and create excellent air circulation. Last, I will talk about the functions and the benefits in this wind tower design. Because the design creates excellent air circulation, it helps to form a comfortable temperature in the classroom, and it also helps students can concentrate on the class. And this design can also help us reduce the installation of the air conditioner, so it helps energy saving and carbon reduction.
Now I'm going to summarize our conclusions. So our school is made of many eco-friendly materials and recyclable materials. They both aim to improve our students' environmental consciousness. Other than that, our unique designs such as wind tower and roller shutter, they can both adjust the temperature of our building without using the air conditioners that might pollute the air. Students can have a more comfortable and a more healthier learning environment. Last but not least, we provide e-scooter. This e-scooter is powered by the electricity that produced from the solar panel. Students can have some fun and excitement while they ride this e-scooter to go home or to come to school. And this is our references. Yeah, that's all for Lignum Vitae Academy. Thank you, everyone.
Questions from judges? Yes, Sherry.
I want to say great presentation, and you are the only team I heard about the pollution for solar panel, and you know how to solve the problem. In Taiwan, many places use solar panel to be in the green energy. In fact, they are also another pollution. But your school can use this. It's really impressive, like how to use the waste. Very nice. So I want to ask this: who find this and who find out the solution for the how to use the waste?
And it's me.
Mm-hmm.
We just search the resource online on the website, and I searched a lot of many reference to expand the solar panel, how to deal with the waste of the solar
panel.
Thank you. And I have second question, sorry. About the wind tower, So it makes sense, like if when your heat go up, you have cool air inside, but Taiwan, usually the summertime, it can be very hot. It can be 37 degrees outside.
Oh.
So how can you make indoor cooler?
The air circulation can make the indoor air lower to nearly 29 degrees Celsius, and it is in summer. So, and the outside maybe is the 31 degrees Celsius, and it can cooling down the classroom and makes the classroom more comfortable.
Although the temperature decrease is not very much, but it still have the effect and is eco-friendly, so the wind tower is good.
Yes.
I think you guys did a great job of introducing some very technical issues with the energy, so I appreciate that. That means maybe my question is not a fair question because it is a bit technical, and so we'll do our best with it. Okay. You mentioned electrolysis as one of the processes that you're going to use for separating hydrogen and oxygen. Right? Electrolysis is a very energy sort of draining type of process. You've already got your solar panels charging e-scooters. We've got lights that still need to be on in classrooms, and now we have electrolysis to power. Do we have any idea about whether our renewable energy sources are going to be enough to cover the energy usage of our school? Is the input and the output going to be neutral, or will we still require some other energy sources?
Like, we hope it is equal. So the electricity from our solar panel and the power generating tiles will store all the energy that just down below the water storage layer. And the power generating tiles that I just mentioned, we also build it on we also put it on the stairs so it can generate more electricity. And so, like when we need to electrolyze the water, maybe it will just use all of our energy. But I think it can still light up our classroom.
So just ask all the students jump out of the fire.
I was thinking we could put little pedal bikes in the classrooms, all right?
So never don't buy home.
Thank you.